So let's discuss question number 50 and 51. This is a common data question from test 5 from industrial engineering. Okay, so two lathes and the time that is required to make one component and the cost is given. So let's first make out, just write down. So this is a capstan lathe and the other is your center lathe. Okay, so first let's go bit by bit because it's a common data question, so we can just consider individually. So on time basis, what is the break even? So let's first write down in terms of time only. So initial setting time is 2 hours for capstan lathe, 15 minutes, 1/4 of the hour for center lathe, and operation time per component it takes 4 minutes. Capstan lathe is fast, and 25 minutes for center lathe. Okay, so in terms of time, what is break even? So break even here means how many components will I produce in each such that the time is same. So either if I go by capstan lathe, okay, this is in terms of time, this is the initial time. Okay, I mean capstan, let's write clearly. Let's cancel these. Okay, so what it means is that if this is my capstan lathe, okay, quantity, or let's say time, so initial time is same, right? And on x-axis I'm plotting quantity. Initial setting time is same, and then as I'm operation time, if I add operation time, let's say, so this is the initial time and this is the operation time, which will increase as you go on producing quantities. So these two together will start from here. This is your total time. Now what he says is that the total time, okay, how many components I should produce for both, I mean minimum components which are produced in capstan and center lathe, so that the times are equal for capstan and total time for center. So let's say if I produce Q, okay, Q, so the initial time is 2 hours. 2 hours into 60, that is 120 minutes plus, so 120 minutes plus, let's say Q quantity is produced in capstan, Q amount, so Q into 4 will be the total operational time for those Q. So this will be the total time that is taken for producing Q quantity. Similarly in the center lathe, it is 1/4 into 60 is the initial setting time plus 25 minutes it takes, so 25 into Q. Okay, the idea is what should be the minimum Q such that time is same for both. Okay, otherwise you will be losing, right? I mean if you make less than this. So 120 plus 4Q is 15 plus 25Q, so that comes out to be 105 by is equal to 21Q. Q is 105 by 21, and that is basically 5.5. so in terms of integer, it's just 5 components. So what it means is that on time basis it is quicker to produce components on a center lathe less than 5, but for a batch of 5 or more, the capstan lathe is quicker to use. So obviously, I mean if you have less than 5 components, your center lathe is best, right? Because less than 5, let's say 4 components, your center lathe will just take 15 plus 100, 4 components, so 4 into 100, 25 into 4, it's 15 plus 25 into 4 is 100, 115 minutes, whereas your capstan will take 120 plus 4 into 4, it is 4 4 16, 136. So less than 5 components, center lathe is best, is quicker, right? And greater than 5 components, capstan because only the sending time is something which kills the capstone. Okay, capstone is quick. So all these analysis can be done. So this is the 5 is the break even in terms of time basis if you want to use capstone. Okay, so the answer is, for the 50 bit, the answer is D. In terms of cost, so let's say, okay, so let's write down capstone and center. The initial cost per setting hour is 10 rupees and this is 8 rupees. And just remember that initial setting it used to take 2 by 4 and this is 1 by 4. And operation cost, that is cost per hour of operation, so this is also rupees 5 and 8. So let's say you're producing Q quantity. So by capstone, what is the total cost? The capstone, the initial fixed cost is rupees 10 per setting hour. The setting hour is 2 hours, so it is 20 rupees, right? It's 20 rupees for the fixed cost, right? And for the operational cost is, it takes 5 rupees per hour of operation. So for each component, each component we can produce in 4 minutes. So for each component it is 4 by 60 is number of hours for each component into 5. So this is the cost per component, and if I am producing Q, so it is 20, so Q by 3 rupees. 4, that is 15, 5 by 3, Q by 3 rupees. So the total cost is 20 plus Q by 3 if you are using capstone. Then if you are using center lathe, the fixed cost is 8 rupees per hour and hour is 1 by 4, so it is 2 rupees. And the operational cost is, let's calculate per component how much is the cost. So the time taken for each component is 8. The cost is 8. It takes, let's go back to the table. It takes 25 minutes for each component. So number of hours for each component is 25 by 60. This is the number of hours for each component. The component is, let's say Q components are produced. So this is the number of components that is produced, okay, and in 1 hour, and for hour the cost is 8. So 25 by 60 into 8 is what is the cost per hour, and into Q is the total cost. Okay, so this becomes 25. So let me cancel 25, 5 5s, 5 12s into 8 Q, and 8 4 2s, 4 3s, so this becomes 10 by 3 into Q. So the total cost is 2 plus 10 by 3 Q. So at break even, these two are to be equal, and so that is 18 by 9 by 3 into Q, that is 6. Okay, so if I produce less than 6, it's better to produce on a center lathe, and above this quantity capstone lathe provides the cheaper method. So that is what is known from this, right? So the break even in terms of cost is 6. Answer is C. So just understand is that you have to just calculate. This is a good problem. You're comparing two methods in terms of time and in terms of cost. Okay, and we get to know that center lathe for less than 6 components, time cost wise it's better, and above 6 it's better to go for capstone. Thank you.